Hello everyone, Dr. Phil back here with you. We're going to start getting into a little bit of the nuts and bolts here of Apollo now. We're going to talk a little bit about, once we have some data in there, how we analyze it, what it can tell us, and that sort of thing. So to begin with, we're going to just start with a sort of a gross overview. I've selected the data button and the cycling tab, so we're just looking at cycling information here. And we'll start out on the performance screen. So basically you end up with several things in this layout that are important. Over here, we have sort of a Microsoft Excel or matrix view of the particular dates, the training stresses, as well as test efforts done by the particular athlete. Over here, we have an overview graph, an effect curve, a predicted performance graph, and a training load graph, for lack of a better word. Here we have graph dates, so we can set these to look at different date ranges very easily. So let's talk about the first thing you notice here. Up at the top left is the overview graph, and you have three different lines on here. We have negative training effect, positive training effect, and performance curves. If you double click on the graph, it'll blow up to full screen and we can get a little bit of a better view here. So the positive training effect is basically all the good stuff that happens to your body with training. The red line is the negative training effects, or the fatigue, for lack of a better word, that you get from your training. And the green curve is the performance, or how we expect you to perform given the particular test you tell RaceDay about. I'll get to that more in a minute. If you look over here, you have an effect curve. What this graph in RaceDay tells you is how much effect, for better or worse, training on any given day will have on a race day in the future, here called day 0. So if we blow this up, what you can see is if day 0 is the day of the race, and this is days before the race, so 10 days before, 20 days before, 30 days before, you can see for this particular athlete, this curve sort of ramps up. So the closer you get to the race, the more important the athlete's training is. And that makes some sense. But what's interesting is you see here maybe 10 or 7 or 8 days out, because here it's day 7, it lights up when you click on the graph itself, you'll see all of a sudden the curve takes a dive. And in fact, if you look real close, here's a line where it says 0. There actually comes a day where training has a negative impact on how well the athlete will perform. This one graph is really the thing that makes RaceDay so powerful. It allows you to plan exactly the best way to build and taper the training for the race, because this curve is different for every athlete, and in fact, in the same athlete, it's different in every sport. So what this allows you to do, by clicking through swimming, cycling, running, etc., is set up a sport-specific build and taper of training to get your optimal performance on the day of the race. This has been hugely beneficial to my athletes. Now, of course, we have a basic training load graph here, so we can see a bike score or training stress measurement for each day as we get on through the months. It's pretty self-explanatory. Over here, we have a predicted performance graph. The black dots are the actual performances. The green, the black dots are the actual performance data. The green line is the prediction of the model. And what you can see here is that we have a pretty good model. These both, their best possible score is 1. So what this is basically telling you is that 80% of the variation in performance is accounted for by variation in training. So that's pretty good. And that remaining 20% may be due to other things, sleep or hydration or eating habits, things like that. But we have a pretty good relationship now between training and performance. Now, these numbers are actually relatively low, and the reason for that is the way this athlete's performance in particular was measured. This was a subject in a research study we were working on. That doesn't really make any difference to you. You would interpret the graphs the same way no matter what the predicted wattage was. So if we click over now one more tab to the training tab, we can see a couple more graphs. We can look at distance trained. Now, because this was done in a laboratory, they didn't actually ride any distance, so this particular graph is blank. If we click over here, we can just look at time if we'd rather think in minutes rather than in terms of training stress. Down below here, we can look at the actual training stress and intensity graphs and the training power in terms of both the average power and the X power, or for lack of a better term, it's a average power that is normalized and adjusted to account for both the variation and the intensity of the session. In other words, it's telling you a bit more about how the power may have, the power output or the training stress may have felt to the body. So that's really what these are good for. If you click over to the Records tab, we can basically set up graphs where we can look at different parts of the season and set up curves and look at personal bests. So for instance, for these particular dates in question, we have a red curve, a green curve, and a blue curve corresponding to some of September and October, some of October and November, and some of November and December. And you can see we have three different curves. So what we can see looking at this particular graph is that if we just zoom in using this tool on this side of the graph, we can see that from the early part of the season to the later part of the season, this athlete's sprint power improved. In fact, it improved by, well, just about 200 watts or so. So that's how we tell that for any given performance measurement we want to think in terms of that the athlete is getting better through the season or not. And if we're not seeing the athlete improve due to training, that means we should probably change the training schedule. Now, if we'd rather just look at a particular interval, this is looking at all intervals. So it's asking the question, what's the best the athlete ever did at 1 minute, or 2 minutes, or 5 minutes? You get the idea. But if we click over here to the chosen interval, we can pick out a particular interval. So let's say we wanted to look for an interval of 1 minute, and we wanted to find 18 separate samples in terms of how well the athlete did. Or actually, given this athlete, let's go for 10 seconds since we're really working on sprints. And let's click the refresh button. It's going through all the athlete's files, and now we can look and watch over time how the athlete's sprint power improved on the whole. So this would give us the idea that our training program was actually working for the athlete in question. So that's just a brief overview about how I use some of these tools. Well, before I go, I guess I should talk about the distribution graph. This allows you to see how much training they did in any particular training zone. Now, for this athlete in particular, this isn't so informative for us. As I said, this was an athlete in a training study in a laboratory. So we can see they were either cycling really, really easy or doing really, really hard intervals without much in the middle. Your graph would probably look something much different if you're training for triathlon or some other open cycling sport rather than a research study.